Okay, so now we're going to get into something called the factor theorem. The factor theorem is very similar, you'll find out, to the remainder theorem. The only thing is, our remainder is 0 when we use the remainder theorem for the factor theorem, because if it factors, that means there's no remainder. So thus, the remainder must be 0. So here's our first example. We're going to use synthetic division to divide this polynomial function by x minus 4. So in this case, again, we just look at it. We have x minus 4 is equal to 0. Therefore, x, we're going to say, is equal to 4. So we have a 4 on the outside. Okay? And we're going to plug in this equation here. And that's going to be, we have 1x squared, and we have 2x's, and we're going to subtract 24. Okay? Well, we carry down the 1. 4 times 1 is 4, which gives me 4. Add these together, I'm going to get 6. 4 times 6 is 24. Add these together, we get 0. So my remainder is 0. And if I was to write this out, we know now that we could say that x squared plus 2x minus 24 is equal to, well, we know we have x minus 4 multiplied by, remember this is my x, and this is going to be 6, x plus 6. And if we expand it, we'll see that is true, right? 4 times 6, 6 minus 4 is 2. Okay, so now let's look at the factor theorem. Now we're going to use the factor theorem. Okay, so we're going to put in P4, which is the same as 4 squared plus 2 times 4, and then we're going to subtract 24. All right, now 4 squared is the same as 16, and then we're going to plus 2 times 4, which is equal to 8, and we want to subtract 24. See what happens. 16 plus 8 is 24, subtract 24 is 0. So the factor theorem, when we do this, it's equal to 0. Kind of like what we said. Okay? So, here we go. So write a binomial with the integral coefficients of the polynomial px. So write a binomial factor with integral coefficients of polynomial px. So here we want where it's 3. So in that case, that means one of the factors, that means we know here when x is equal to 3, we have a factor. So then x minus 3 is equal to 0. So my one factor is x subtract 3 is a factor, okay? Or another case, if it's a factor, it is a root or an x-intercept. Let's take a look at this next one. We're just going to do the same thing, kind of solve for it. So I have x is equal to negative 2 over 3. Solve for x. Well, multiply both sides by 3, so I get 3x is equal to negative 2. And then here I'm going to end up getting 3x plus 2 is equal to 0. And so this is my factor, so I know 3x plus 2 is a factor. Okay? All right. Now let's look at class example number 6. This one says we have P5 is equal to the polynomial function with 2, which is equal to 0. So determine the second degree of the polynomial function. So we want to know what is the second degree factor of the polynomial function. So these two here obviously are factors. So looking at this, I know that 5 is equal to x, so then x minus 5 is one factor. My other factor is negative 2 is equal to x, so then x plus 2 is another factor. Now it wants to know the second degree of it. Well, that's easy. We're just going to multiply these out. So if I multiply these out, I'm going to end up getting x squared minus 3x plus, or sorry, subtract 10 is my answer. Okay? All right. Now we're looking at class example 7. It says, use the factor theorem to decide which of the following is a factor of the following polynomial function. So we're using the factor theorem here. So basically this one here, we're saying x is equal to -2. So we're going to put in -2 to my polynomial function. So we want p of -2. So we're just putting in -2. That's going to be 4. And then we're going to have -2 to the power of 3. And we're going to subtract 16 to -2. And that is squared. And we're going to minus -2 and plus 4. So now when we simplify this, -2 to the power of 3 is going to be -8 times 4 is -32. Okay? Now we have -16 times 4, because -2 squared is 4, which gives me -64. And then we have plus 2, -2 times negative is -2, and we have plus 4. This ends up equaling to -90. So looking at this, we know that x plus 2 is not a factor. Okay, so not a factor. Why? Because it doesn't equal to 0, so it cannot be a factor. Now let's look at the next one here. We have 2x minus 1. So in this case, we know that x is equal to 1 over 2. If we make that equal to 0 and solve, x is equal to 1 over 2. Okay, so we want p 1 over 2. Now we're going to plug that into everything in here. So I'm going to have 4 times 1 over 2 to the power of 3 minus 16 times 1 over 2 squared minus 1 over 2, and then I'm going to plus 4. Alright, so now I'm going to simplify these out. 1 over 2 is the same as 1 over 2 to the power of 3 is the same as 1 over 8 times 4 is 1 over 2. 1 over 16 times 1 over 2 squared. 1 over 2 squared is 1 over 4 times 16 is going to be 4. Then I have minus 1 over 2 plus 4. I look at this, these 4's cancels, these cancel, I'm left with 0. So then we know that 2x minus 1 is a factor. Okay? Alright, last question. Show that 1 is a root of the equation x cubed minus 9x squared plus 20x minus 12. Okay? And then it wants us to find the other roots. Okay. So first of all, when it says roots, that means if it's a root, it must be a factor. So first we have to show that 1 is a root, so that would mean that x minus 1 is a factor if we're trying to show that 1 is a root, because this makes us x is equal to 1. So we're going to go P1 is equal to 1 cubed minus 9 times 1 squared plus 20 multiplied by 1 minus 12. Okay, and we have to show that that's equal to 0. If it's equal to 0, then it is a root, or a factor. Factor and roots are essentially the same thing. Okay, so this is going to be 1 cubed is 1 minus 9, and then we're going to go plus 20 minus 12. Okay, so I have 20 plus 1 will give me a total of 21, and negative 9 minus 12 gives me 21, so this is actually equal to 0. So 0 is equal to 0. That means it is a root. Alright, so now that I know that's a root, we're going to try and find my other root. So I'm going to use synthetic division to figure out what's happening here. So we're going to go 1. And we have 1x cubed. Then we have 9x squared. And then 20 x's. And then minus 12. So we carry the 1. 1 times 1 gives me 1. 1 plus negative 9 is going to give me negative 8. So it's going to be negative 8. Negative 8 and 20 is 12. 12 times 1 is 12, and that's 0. So this part here is going to be x squared minus 8x plus 12. Now, factoring this shouldn't be too bad. If we factor this here, I know that this factors out to, just do a quick factor in my head, it's going to be x minus 6 and x minus 2. We could do the box method or whichever way you want to factor that. So now we know all three factors are x minus 1, x minus 6, and x minus 2 are all factors. If I multiply those together, it is going to give me x to the 3 minus 9x squared plus 20x minus 12. And that is all we do.